Hey y'all. Okay. Well, I'm not back at school. So, anywho, I'll be back next week. I gotta stay home with the kids. All's good. I feel fine. But it's just Cato's policy is really strict, and so I'm not there right now. But we're gonna keep rocking and rolling as if I was there. No big deal, nothing to be missed. I already had it planned out in your module, and we're just going to roll with that. I'll just be using the recordings, so you guys are going to have to just bring your headphones and listen to the recordings with the substitute. I apologize, but there's just nothing I can do, y'all. Okay, so I know you probably have questions about the canned goods. And I don't know why this video is not recording my lips with my words. So, I don't know. Close your eyes and just listen to me. But the we are still going to do that bonus, you guys. Unless something wild happens, I'll be back at school the 7th. And so you will have the 7th, the 8th, the 9th, the 10th, 4 days to turn in your, cans to get your bonus. Okay, so I'm sorry that I haven't been there to be able to do that, but we're still going to have that opportunity. I still want to participate in this and help out the people in our town who need these canned goods. So we will still do that. Mark your calendar, put it in your phone, set a reminder to bring your cans on the 7th, the 8th, the 9th, or the 10th. Okay, so today our lesson is 14-3. So let me make myself small and make this big. Okay, 14-3 is on page 198. So the good thing about this is you can pause me as you need, but you need to get your textbook out. You need to go to page 198. Because I'm not in class this week, you will have to submit your notes. So everything that I write, you need to keep up with me and make sure you have notes. Tomorrow you do have a quiz. It is going to be open notes. So you need to make sure you have all your notes and make sure that they are good. Tomorrow's quiz is on 14-1, 14-2, and 14-3. So make sure you have all of those lessons with you in class on Tuesday so that you can complete that quiz to the best of your ability. Okay? All right, so here we go with this lesson. Our lesson for today wants us to determine the points of concurrency, which is what we've been doing this whole time, but this time we're doing perpendicular bisectors and angle bisectors. Remember that a bisector cuts in half. Okay, so we are going to be cutting the segments in half so we can have a perpendicular bisector, and then we're going to be cutting the angles in half because we're going to have an angle bisector. Then it wants us to use the points of concurrency of the perpendicular bisector and the angle bisector to solve problems. If you remember back last week, we were working on the riddle that we were trying to solve. Let me rearrange this, guys. Let's see. We're working on this riddle trying to find this missing treasure. Okay, so it says the third part of the poem tells you how to determine the combination of the lock. We're skipping that. Okay, we're not going to do number 1. If you're totally into this, you can do number 1 and that will help you find the combination. What we're going to go on to is the math, okay, which deals with these next 2 highlighted terms. So it says, Al, Jeff, and Cal found the treasure by locating the point of concurrency of the altitudes of the triangle called the orthocenter, which we've already done that, and the point of concurrency of the medians, which is called the centroid. So this is what we've been working on. That's what your quiz is on tomorrow. It includes those things. Luckily, like I said, you'll get to use your notes. Cal tells Al and Jeff to learn about 2 more types of points of concurrency called the circumcenter and the in-center before they design the nature preserve. They start by locating the coordinates of the circumcenter of triangle A, G, and C. So what the world is a circumcenter? It says the perpendicular bisector. So perpendicular bisector of the sides of a triangle are, this concurrency is called the circumcenter. Okay, so you need to flip back in your notes, which I'm just going to use my teacher book, to get the midpoints of this triangle. So last lesson we found the midpoint H, E, and N. And if you remember, we used the formula x plus x divided by 2, comma, y plus y divided by 2. That helped us find those midpoints. So I'm going to go ahead and mark those midpoints on this triangle so that we've got those. H is located at 2, 4, 6, 12. So 2, 4, 6, 12. That is H. E is over here at 22, 4. So 24, 12. That's E. And N is located at 18, 0. So that, that saves you a little bit of time because you already have those midpoints. But just remember, if you didn't have the midpoint, you would do x plus x divided by 2, comma, y plus y divided by 2, and that's going to give you the midpoint. Well, why do we need the midpoint? We are going to be drawing the perpendicular bisector. The bisector is going to take this segment CG and it's going to cut it in half. Well, the half point is the midpoint, E, so that's why we needed that. Now, we need it to be perpendicular to this segment, okay? So we need the slope of CG, okay? Slope of CG. We also did that on lesson 2, okay? Let's see where we found that. Did we find the slope of CG? I'm not seeing it, but I sure thought we did. That's okay. We can do that really quickly. It won't take us long at all. You can use the ordered pairs, or you can do rise over run, which is what I'm going to do. From this point, I'm going up 1, over 1, up 1, over 1, up 1, over 1. But remember, we're counting by 2. So I'm going up 2, over 2, up 2, over 2. But still, 2 over 2 is 1. We are going left, which makes it negative. So the slope of this is going to be negative 1. So I want this to be perpendicular. Okay? Perpendicular slope is the opposite reciprocal. So what's the opposite reciprocal to negative 1? Positive 1. So that means I'm going to, from E, go up 1, right 1. Up 1, right 1. It's so hard to see. Okay. I think that's right. Or we could flip it and go down 1, left 1. That's actually easier to see. Down 1, left 1, down 1, left 1. Now, I am going to use a straight edge. You need to use a straight edge always. Make sure you have a really nice straight line because, again, we are looking for the point of concurrency. You can draw your little box right there because that is a perpendicular line. The point of concurrency should be somewhere inside the circle. So that's why I didn't extend it all the way. I just kind of stopped right there. Hopefully that will get us close enough. N is super easy. The line here is a horizontal line with a slope of 0. So I need a vertical line. Okay. So it looks like we already have that point right here because those two cross right there. We just need to confirm it with H. So again, I need to find the slope of these. So I'm going to rise 2, run 1, rise 2, run 1, which remember we're actually rising 4, running 2, but it's going to work itself out. AC is rise 4, run 2, which still ends up being 2 or 2 over 1. So I need the perpendicular slope to that. So this one's positive, so mine needs to be negative. And then you take the reciprocal, which is going to be 1/2. Because if there's not a denominator to flip it, you have to put it over 1. So that's going to be 1 over 2. So from H, I'm going to go down 1, that's my negative, right 2. Down 1, right 2. Down 1, right 2, and sure enough, it's right where the other 2 meet. Again, I'm using a edge. It's very important that you have straight lines because we're looking for that point of concurrency. So I'm looking for this point right here. That is going to be the circumcenter. Okay, so your circumcenter is found using the perpendicular bisector. So step 1, locate midpoint. Okay, so we're looking for the midpoint. Step 2, identify. That's not how you spell identify. I-F-Y. Anyways, y'all know I suck at spelling. Identify slope. Okay, number 3, find perpendicular slope. Number 4, plot / draw line. So that's what you're going to do each time. You're going to locate the midpoint. You're going to identify the slope, find the perpendicular slope, plot / draw your line. And remember, you're looking for the slope of the line that it is on. Okay? So for E, we're looking for CG's slope. For H, we're looking for AC's slope. For N, we're looking for AG's slope because it's on that segment, and then you draw your perpendicular bisectors. Okay? Now, they want you to find the distance from Q, which they're calling this point here Q. And you can see that he calculated it to be 18.6. If we look at ours, it is at 18.246. So we definitely got Q to be at 18.6 as well. We did it by sketching the perpendicular bisectors. Okay. Well, now they want us, it says, the circumcenter of a triangle has a special property. Okay, they want us to figure out what that special property is, and I'm going to just go through this quickly and kind of tell you what's going on. So we're looking for the distance from Q, which is that circumcenter, to A, Q to A is a vertex, Q to C, which is a vertex, and Q to G. So they want the circumcenter to each of the vertex. We could take the time to do that using the distance formula, which is x2 minus x1 squared plus y2 minus y1 squared. But because we're doing this via video, I'm not going to take the time to do that. I'm just going to tell you the distance. The distance from Q to this vertex A is, wait for it, 6, 10. Okay. The distance from Q to C is 6 square roots of 10. The distance from Q to G is 6 square roots of 10. So what do you notice? What do you think that special property is? Well, the circumcenter to the vertex will always be the same. Okay, so it is equal distance from each vertex. We're going to write that on the next page, page 199. So page 199, number 4 says, the distance suggests that the circumcenter of a triangle is equal distance from 3 vertices of the triangle. Write a convincing argument that this special property applies to all triangles. Well, we're not going to write a special property, but this is what you need to know. The circumcenter triangle is equal distance from all 3 vertices of a triangle. This is truth. Okay? It is going to be the case every single time. If you want to know what the book says, the points on the perpendicular bisector of a segment are equal distance from the endpoints of the segment. If the perpendicular bisectors of line segments CG and AG intersect in point Q, Q must be equal distance from points C and G and equal distance from A and G, and therefore it is equal distance from A, C, and G. That is, you don't have to know that. Okay, what you have to know is that the circumcenter is equal distance from all 3 vertices. What I bracketed in right here is what you need to know. That will be the case every single time. Now, number 5 asks us to draw a circumscribed circle. Okay, well, what is a circumscribed circle? A circumscribed circle is a circle that contains all of the vertices of a polygon. Okay, so here is our polygon. We're dealing with a triangle, but it could be any type of polygon. And that circle is going to go through each of those vertices. So it's going to be kind of like that. Mine's not really great, but it's going to be on the outside of that polygon going through each of the vertices. So if we come back over here to page 198 and we look at this, I want you to do your best to sketch this for me, with me, and it's going to be a pretty circle. What we would do is, if I was in class, we could get out our compass. You would put the needle right here in the middle at your circumcenter, and then you could use that compass to draw yourself a beautiful circle because it's equal distance from that. But since we don't, we're gonna just sketch this out. Mine already looks horrible, but it's something like that. That's embarrassingly bad, but that's what it would look like. Okay, so if we had one of those fancy compasses, I don't know if you even remember what a compass looks like, but it has like a little pencil and then it has a needle and they're like attached, and you put the pencil or you put the needle down and then you can spin the pen around and it will help draw that perfect circle. Well, this is possible because of that circumcenter. The circumcenter is equal distance from each of those. It's like if you play baseball or softball, this circumcenter would be that pitcher's mound, okay? And you put that, we always did it with a rope. And so we would put the nail down directly in front of the pitcher's mound, right in the middle. You take the rope, you draw it out, make sure it's straight, and then you go all the way around the pitcher's mound so that you have that really pretty circle right in the middle of the field. That is done just like this, okay? Except for we don't have a rope and a nail and we're not on a softball field, but that's the concept of what we're doing, okay? All right, so that is a circumscribed circle. I knew I was going to say that. A circumscribed circle is where it goes through each of the vertices and it goes around just like that. Y'all better not make that into TikTok. I do not want to see myself on y'all's TikToks. Okay, now the next part of this lesson moves on and we are going to be talking about the other point of concurrency, which is a incenter. Okay, the incenter was also described on this first page. Okay, on page 198, it says the angle bisector of the angles of a triangle are concurrent, and this point of concurrency is called the incenter of the triangle. Okay, so the circumcenter is made with the perpendicular bisectors, which is going to be the midpoint. The incenter is made with the angle bisectors. So we're going to take each angle and we're going to cut them in half. Now, we are not going to get out our protractors and we're not going to do this super fancy. What we're going to do is we're just going to do our best to sketch this out. So what we're doing is we are taking each angle and we are cutting it in half, okay, as best as we can. So they already give us their idea of where it is. So 14.9. So here would be 14, maybe a little bit past, up past 8, 2, 4, 6, 8, a little bit past, somewhere inside that box. Okay, and you can look at yours and see where that's at. It says number below, carefully draw 3 bisectors of the angles of triangle AGC. Label the point of concurrency I. Does your drawing support his results? Now, remember, an angle bisector is supposed to cut this angle in half. So, I'm going to kind of sketch those out just to start with. So you can see what I did to begin with is kind of just start right here, and y'all, it's really just a sketch. Okay, we're not going to take the time to do this super fancy, and then I'm going to just kind of line up my straight edge, line up my straight edge, oops, and then line up my straight edge. Okay, so you can see, obviously mine is not done great because I did not get a good point. Okay, but this is a sketch. I'm doing a sketch, so it's not always going to be perfect. And like on a quiz like this, you would not have to do one of these. I'm going to make this work for our lesson. So I'm going to take that one there. So if yours doesn't work out like mine, make it so that we can have a good point. And I'm going to say that this point right here is going to be my incenter. Okay? And I'm going to label that I. And that's done by using the angle bisector. So when you do that, if you did this correctly, if we measured it out, this angle over here, down here at the bottom, should be exactly the same as this angle here. Those should be exactly the same because you have a bisector. Same thing here. This side should be congruent with that side. And this side should be congruent with this side. So those should be congruent angles because you cut those directly into half. Okay? So that is our I. Now, it says to explore the special property of an incenter, Al needs to calculate the distances from the incenter to each of the 3 sides. So, I am going to again tell you this information. We're not actually going to do any of this down here. What we're going to do is we're going to sketch this out. Oh, and I should have extended these all the way across. So here, and here. Hold on one second. I think I might have done something wrong. No, I didn't. No, I didn't. Okay, no, everything's fine. So we're going bisecting. We're going to cut this across here. We're going to go all the way to those edges. And they just labeled this BLM. Those are not the midpoint. Okay, so those are not the midpoint, so don't think that those are the midpoint. They're not. They're just a result of being bisected. Okay, so you've got your angle bisector. Now, from that, we have down here at the bottom what's called an inscribed circle. So an inscribed circle, come over here to your math tips. It says, since the incenter is equal distance to all three sides. So what that means is that the distance from the incenter to the edge, not the vertex, the edge. So from the I to B, the I to L, and the I to M, the distance from the sides is all going to be the same too. So that's going to be the radius of a circle. The distance from here to here is the same. The distance from here to here is the same. So we're dealing with a radius. It says it is the center of the circle with a radius equal to the distance from the incenter to the sides. This is called an inscribed circle. Okay, so since this is a radius, and this is a radius, and this is a radius, then again, I'm going to draw myself a circle. Okay, I'm going to do the best I can. This one is inside the circle. It is an inscribed circle. Take a look at the books because theirs is perfect. So they've got their angle bisector, just cut the angle A in half. They have their angle bisector that cuts the angle G in half, the angle bisector that cuts C in half, and they all come together at point I because theirs is perfect, unlike mine. So then you can see I have these marked right here as being the same. They are congruent to one another. They are a radius. From I to the edge, from I to the edge, from I to the edge. Those are all radiuses, and they are all congruent. What we also know is that this segment here is congruent to this segment. Those two are going to be congruent. Same thing here. This segment down here is congruent to this segment down here. So from A to L and A to M, they are congruent over here. M to G is congruent to B to G. Those are congruent as well. So that's what an incenter shows us. An incenter is the result of an angle bisector. Okay, that point of concurrency is called our incenter. The incenter is equal distance from the side. Then you have an inscribed circle, which is inside the circle, creating these equal parts. Okay, so that is that. Number 12 says, can an incenter of a triangle lie outside of the triangle? An incenter cannot know, okay? Because it's an angle bisector. The angles are on the inside. So they're going to meet on the inside. So the book says the incenter is the point at which the angle bisectors meet. The point always has to lie on the interior of the triangle. So exactly like I said, you're splitting the angles. It has to be on the inside of the circle. Now, you are going to be working on this homework assignment. You're going to be doing 14. You do not have to do number 18 because number 18 has that really big point, 0, 20, so you don't have to do that one. The other one, number 19, I do want you to use. You can use a little piece of scratch paper to do that. But what I'm going to kind of walk you through this, and you can do this with me. I'm just not going to write the answers down, but I'm going to talk to you about it to make sure you understand what's going on. So, it says, if PX equals 18 mm. Okay, so PX is from here to X. This is it says circumcenter P. Okay, that's why it's coming from the vertex to P, vertex to P, vertex to P. Okay, so they're telling you that is a circumcenter, which is equal distance from the vertex. Okay, so these are all going to be the same. Okay, they're going to be equal distance because from the circumcenter to the vertex, circumcenter to the vertex, circumcenter to the vertex, they're all going to be the same. So that should help you answer number 14. Then number 15 says if WX, so this segment right here, is 12, they want to know what the whole segment is. Well, we have to think about what is W. W is the midpoint. So if this is 12, what is this? Once you know that, add them up and you answer. Okay? Now, below it says given ABC is the end center of D. So the end center is the one that we did second. It is equal distance from here to the sides. Okay, from there to the sides. So let's see what it says. If DE is 3, then what is DF? And I'm going to tell you it doesn't look like it's the same, but I'm telling you that's what the rule is. That if this is 3, then that also has to be 3. So even though it doesn't appear to be 3, it is because your end center is equal distance from the sides. Okay, so even this side over here is going, if we continue that line on, it's also going to be 3. Okay, then it goes on, 17 says angle CAB. So this large angle here, angle CAB is 90. Angle CBA is 25. So you know 2 of the angles of your large triangle. Well, how many degrees is an entire triangle? You should know that. Whatever the answer is, you can subtract out your 90, subtract out your 25. That's going to give you ACB. Whatever the remainder is ACB. Well, then they want to know what's ACD. ACD is the result of an angle bisector. What does an angle bisector do? That's going to help you get that answer. Then for number 19, what you need to do is graph these out. You're looking for a circumcenter. Okay, I gave you the little notes on how to do that. You have to locate the midpoint, identify the slope, find the perpendicular slope, draw your line. Okay, so that's how you're going to do number 19. If you get stuck, ask your friends, ask for help. I will post a review video showing you how to do this that you can watch before you test tomorrow. But remember, you do have a quiz on Tuesday, and you are allowed to use your notes. So make sure you have good notes. What I need you to submit to me today is the notes that we took in class, and then these homework problems. If you get all that submitted to me, that's all that I need from you today. This video is 33, almost 34 minutes, so you still have time at the end of this class to get this done and submitted to me so you don't have to do it at home. For those that are virtual learners, make sure you get all this done and submitted. And I promise you I'm going to be working on grades, but it is very difficult to get anything done at my house with 3 toddlers. I'm currently recording this video at, can you see that? 11:12 at night. Okay, so the only time that I can get things done is after the kids go to sleep, and since I'm recording videos, it's hard for me to get grades done and survive. But I promise you I'm going to get all of that done. Don't stress over those things. It all will happen. Okay? All right. Well, I hope that everyone is well, and I will see you guys on the 7th, unless something crazy happens. Fingers crossed that that doesn't, and that we can be together for the last 2 weeks of December before we leave for Christmas break. All right. Via video tomorrow.